Uh, in the previous lesson, last lesson, we were discussing is a mathematical proof. Should I explain? Should I explain?
Yes, please.
Asha, we discussed molar gas equation, or it is ideal gas equation. Uh, that is P. That is P. V is equal to nRT. Is it so? This we discussed.
Yeah.
Okay. Now, if you shift V on the other side, it becomes P N over V RT. N means number of moles, V volume, and this is a unit basically. Mole, number of mole, and over volume, and mole over volume is actually concentration. Is actually like mole per dm cube. Units may be any. This is mole per dm cube. So this is concentration. So basically, P is equal to concentration R E. Now, if you have an experiment being gas, the value of R, it remains same. It means it is constant.
Yeah.
T, and that's the temperature. And temperature, if once you maintained in a closed system, it will also be maintained. It will not be changed. It means R and T are constant. That's why if you remove constant, it becomes P proportional C. It means mathematically, you can say pressure is directly proportional to concentration. So basically, this is the relationship between pressure and concentration. And you can say it is a relationship of pressure and concentration. So this is, it means you can say pressure is directly proportional to concentration. And how is it? Conceptually, if you have, what is concentration? Mole per dm cube, number of mole in a given volume. And pressure is force per unit area. And force depends on number of moles or number of particles colliding with the wall of the container. Basically, it is in the if there are more particles in a given area or volume, it would be more pressure. If number of particles are less, it will be less pressure. It means pressure and concentration, they are directly proportional. So can you explain this, what I said?
That they're directly proportional because the other two things in a closed system are constant, so they don't change, which means that concentration is the only one that can change. So pressure and concentration are directly proportional.
Pressure is basically force per unit area, and it depends on number of particles. If there are more particles in a given volume, it will be higher pressure, and it will be higher pressure. The concentration would also be higher. So this is the way. So now you come to Kp expression. The way is same. It means in solution, in aqueous solution, we use the equilibrium constant, that is Kc. But in gases, we can use either Kc expression or Kp expression. Of these two, you can use any one. For gas, you can use concentration Kc, and for gas, you can use concentration and like Kc and Kp both you can use. So this is the point. And now you have N2H2NH3 Kp expression. Kp expression means equilibrium constant in terms of pressure. The NH3, it is P, it is partial pressure of NH3 at dynamic equilibrium, or obviously it depends on number of particles. And partial pressure of H2, this is partial pressure. Partial means individual pressure of H2 and N2. And H2 is raised power 3 because in the equation there is 3. Now, what is partial pressure? Partial pressure, as the equation shows, if you look at this equation, partial pressure, it is individual number of moles over total number of moles into total pressure. Individual number of mole over total number of mole multiply total pressure. It gives the partial pressure of component at dynamic equilibrium. Now, dear sir, if I give you one question, can you try?
Yeah.
Now, question is, you try, please, so that you can go through this topic. Question is this. I write. This is question. In a closed system, in a closed system, three mole of SO2 and 2 mole of O2 are made to react with at a pressure of at a pressure of pressure of 380. At dynamic equilibrium, the number of moles of O2 remained at dynamic equilibrium, the number of moles of O2 remained 1.5 mole. Calculate. Number one, partial pressure of SO2, O2, and SO3. SO3. Number two, calculate Kp. And derive its unit. Derive its unit. Dear sir, are you looking?
Yeah.
This is the question. Can you try?
Yeah. So
As you write the values, SO2 are 3 moles,
oh wait, where's my
O2 are 2 moles,
S
SO2 are 3 moles, O2 are 2 moles, uh,
O2R?
2 moles, 2 moles,
Yeah.
and total pressure is 3 atm
3 atmosphere.
atmosphere. And at dynamic equilibrium, O2 remained 1.5
Moles.
mole, yes. Now calculate partial pressure of SO2, O2, and SO3, number one. And number two, calculate Kp and derive its unit. No, please do it. And you can attempt on the page I have shown.
Is it that?
Good. One. Now, it needs some addition. Okay. It needs some addition. Okay. First of all, look, please. This is I am I'm correcting the parts. This is look, please. This sign is for concentration. Please correct it. This sign for concentration. This is not concentration.
Oh,
okay.
so it should be mole per dm cube. Mole minus 1 dm cube.
Way is correct, but symbolically this is wrong. This you will not show. You write simply like ATM square. You write simply like over here ATM square, and like this. You can put the bracket, small bracket you can add, put our ATM square. That is enough. And yes, please. Good. No, it is right. Up to this point is correct, but it needs some more.
Oh, wait.
No.
There we go.
That's all right. Now this is actually we are dealing with Kp, partial pressure. First of all, you have to calculate partial pressure of each component, like partial pressure of SO3 is formula I have told you in the discussion. Individual number of moles.
P is equal to C nRT.
No. That was the justification. Okay. It means pressure and concentration. The sense is same. You are dealing with the pressure, you are dealing with the concentration, but in gases it is more easier to develop to use partial pressure instead of concentration. This I show you. Can you read this? This is partial pressure. What is the formula?
Individual number of moles over total number of moles times total pressure.
Yes, this is. I know you look, please.
I don't have the total pressure.
Total pressure?
Oh, 3 atmospheres.
3 atmospheres. This was. So basically, this was 3 ATM. The individual pressure of SO3 is one is moles, and total moles are 2 plus 1.5 plus 1. 4.5? Is it 4.5? Are you looking?
Yeah.
The total number of moles at dynamic equilibrium. These are the moles of SO2 at dynamic equilibrium. This is of O2, and that is for SO3. And you will add up these three, 2 plus 1.5 plus 1. Does it come 4.5? Is it 4.5?
Yeah.
To multiply, that is total pressure is 3. Can you calculate 1 divided by 4.5 multiplied by 3? What the answer is?
It's, 2/3.
Hmm?
2/3.
In decimal, if you calculate, three divided by 4.5. Are you calculating?
Yeah.
Divide by 4.5. It comes up 0.667 basically. Is it so? 0.667. This is 18. Now come to P partial pressure of SO2. It is individual mole are 2 over 4.5 multiply, that is 3. You please calculate this. 6 divided by 4.5. It comes out 1.33. You please check. Is it the answer?
Yeah.
Now, O2. Of O2, it was erased. It disappeared. Erase it. SO now of PO2, partial pressure of O2, and O2 1.5 over 4.5 multiply by 3. You multiply 1.5 multiply 3 divide by 4.5. What comes up? Is it 1?
Yes.
It's 1. Achha, now these are the answers of part 1. Partial pressure of SO3, O2 and SO2. Now, is it clear how did I calculate this? Is it clear or not?
Yeah.
Now you put the values in Kp expression. While writing Kp expression, you have to be careful. You will not use the sign of concentration. You write simply P and raised power 2. This is SO3 P raised power 2 SO2 and P raised to power O2. This is 1. This is the expression. Now you put the values. Dear sir, you please erase your work. You please erase your work. Now SO3 is 0.66, 667, and raised power 2 is a square, and SO2, this is 1.33, and O2, it is 1. Now, you simplify this and you get the answer. And the answer is Kp. And the unit is ATM minus 1, ATM inverse. Now, please tell me, is it clear or not?
Yeah.
So this is the way you can deal with Kp. The Kp basically, this is also the constant, equilibrium constant in terms of pressure. Conceptually, it is, the meaning is same, the sense is same, like of concentration, but in gases, we can use pressure instead of concentration. For gases, we can use Kc expression if there is only concentration data is provided, but we can also use Kp expression if pressure is provided. So this is about Kc and Kp. Asha, now, can you tell me the factors which can affect Kc or Kp?
Temperature, pressure,
No.
concentration.
Asha, look, please. I'm putting the question, factors which are affecting the value of Kc or Kp. Not, I'm asking you the dynamic equilibrium, factors affecting dynamic equilibrium. I'm not asking about the factors affecting dynamic equilibrium. Rather, I'm asking about Kc and Kp. Achha, look, please, in the start, if I show you start material, that is intro. In the intro, I told you
Said concentration and temperature.
this was, I told you, I showed you with the help of figures like 40, 20, 20, 10, 10, 5. Ratio is same, but the figures 20, 40 is going to be changed. It means changing concentration. Concentration and pressure is, the sense is same. That's why changing concentration, changing pressure would not affect Kc or Kp. Kc or Kp only affect due to change in temperature. And that's the only factor. It is affected by temperature. It's not affected by concentration, temperature, pressure.
Wait, you said it's not affected, and you said it is affected by temperature.
Only for temperature. Only with temperature.
Okay.
I show you this is. Look, please. Effect of concentration, effect of temperature on Kc and Kp. Effect. This is effect. Value of KCKP only affected by temperature. Change in temperature. If favors the formation of product, means you bring a change in the dynamic equilibrium. If you change the temperature and it results in increase in formation of product, then the value of KCKP would increase. Otherwise, the value would decrease. And this is the major point. Like for exothermic reaction, for exothermic reactions, like for exothermic reactions, like N2, H2, reversible to NH3. Delta H is exo, negative. It means forward is exo, backward is endo. And if you look, another example, 2HI, reversible, H2 plus I2, and this is delta H endo. It means forward is endo, backward is exo. If you increase the temperature, in case of N2, H2, NH3, it will favor backward side. It means product would decrease. When product would decrease, it means the value of Kc and Kp for N2, H2, NH3, it would decrease. But with Hi, H2, I2, it would increase. When the temperature would increase, it will favor forward side because the endo is forward. That's why its value of Kc, Kp would increase. So this is the link with this. And the catalyst would not affect Kc or Kp. It is only affected by temperature. Now, please tell me, is there any confusion?
No.
We are going to stop up to this. If you have any query, any question, you can ask right now.
No.
Otherwise, tomorrow, inshallah, we shall.
Are we going to do KA tomorrow?
KA, and this is a small part remain. Then we shall, inshallah, KA. Okay. We'll go through because now I'm following your syllabus basically. Okay.
That's fine. Okay.
Okay. Allah Hafiz.
Allah Hafiz.